Notes, we're going to combine section 7.5 and 7.6 because it all goes together in talking about trigonometric ratios, or for short, trig ratios. It's the ratio of the lengths of two sides of a right triangle. So you have two sides of a right triangle. It's not a special right triangle, just 90 degrees, and you can do the ratio of the length of the two sides. There are three basic trig ratios. Three basic trig ratios. You're going to make a little chart here. The first one is called sine. Second one is called cosine. And the third one is called tangent. You've probably seen these on your calculator. Why is that not working? Oh, it is working. You've probably seen those on your calculator. Starting from today through the rest of your life, you will no longer call them sin, cos, and tan because you don't know what they stand for. This is sine, this is cosine, and this is tangent. Write those down. And the sine, since they're ratios, yes, they're going to be fractions. Sine abbreviation is SIN. Cosine COS, tangent TAN. Notice I didn't even say it. I couldn't say it. I had to spell it. SIN COS TAN is their abbreviation. And here is their fraction or their ratio. Write it down as is. OPP over HYP, ADJ over HYP, and OPP over ADJ. Write those down. Spell them correctly. I'll tell you what they stand for. And then you're going to need one more section. We'll fill this section in once we know what all this stands for. The OPP stands for opposite. HYP, maybe you guessed it already, is the hypotenuse. ADJ is adjacent. So opposite, hypotenuse, and adjacent. All triangles have three sides to them. So underneath here, I'm going to have you draw a right triangle. Put a 90-degree angle in the corner. Has to be a right triangle. The only one that you know from this diagram is the HYP, the hypotenuse. Hypotenuse is always the hypotenuse no matter what size, shape, or direction your triangle is facing. Hypotenuse is always across from the 90-degree angle. Meaning, if you draw the hypotenuse, no matter how long you extended it, it would never run into this 90-degree angle. So when we say across from it, it means it'll never touch it. Okay, but the opposite and the adjacent, those are the two legs. And we don't know, the word opposite means on the other side of, like if you're talking about opposite sides of a room, not like opposite cold hot, but still, other side of the spectrum. The opposite side in a triangle is the opposite side of an angle, and adjacent means right next to you. So if you were opposite of me, you'd be sitting in the far back corner of the room. If you were adjacent to me, you'd be standing right here next to me. So the only way that we can know which one is opposite and which one is adjacent is to pick an actual angle that we're working with. So let's label this angle A. If that's angle A, then you know that angle A is in this corner of the room. Well, which side is opposite of angle A? All the way over here, not touching it. The opposite of angle A is way over on the other side of the triangle. So again, if I drew the opposite side, no matter how far I extended it, it would never actually run into angle A. Whereas if you drew the adjacent side, let me get rid of that if I can. If you draw the adjacent side, it's adjacent because when you draw it, it actually runs into the angle. So does the hypotenuse, but the hypotenuse is always just called the hypotenuse. So this is going to be the adjacent side, ADJ. The problem is if we took this exact same triangle, didn't change anything about it, drew it over here, but instead of calling this angle A, what if we call this angle A? Well, now these are wrong. Opposite, this isn't opposite of angle A, it's right next to it. So we have to switch places with the opposite and adjacent. So go ahead and draw both of those triangles so that you know if you're working with this acute angle, it's opposite down here. But if you're working with this acute angle, it's opposite over there. And we only work with the acute angles. The 90-degree angles, opposite of the 90-degree angles, of course, is always the hypotenuse. Draw that triangle. We'll come back to this chart in a moment. Actually, let's fill in the chart right now. When you're done drawing your triangle, pause it if you have to. We've got SOH all capitalized, CAH all capitalized, and TOA all capitalized. These are the abbreviations, sine, cosine, tangent. These are acronyms, not abbreviations. They're all capitalized because they all stand for something. The way you say that out loud is SOHCAHTOA. SOHCAHTOA, SOHCAHTOA, say it out loud, SOHCAHTOA, 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 all the way to Mexico. When you're there, cut your hair, stick it in here. Okay, you guys, do you know that even? SOHCAHTOA is something you said to your little sister when you were really way too young. But anyway, SOHCAHTOA. If you can pause it, try to figure out what it stands for, you can. If you just want to give up and have me tell you. If you can remember how to spell SOHCAHTOA, then you can remember that every time you find the sine of something, you're going to use the opposite side over the hypotenuse, SOH. Whenever you use the cosine, you're going to do the adjacent side over the hypotenuse. And whenever you're talking about the tangent, you're going to use the opposite over adjacent. So SOH comes from sine opposite over hypotenuse. COH comes from cosine adjacent over hypotenuse. And TOA does not have hypotenuse with it. It's opposite over adjacent. Okay, and you can write all this down and you can draw these triangles and you can have everything labeled and you're all fine and dandy, but now you're like, now what? What do I actually do with this information? It says that it is a ratio of the lengths of two sides of the triangle. So a sine is a shortcut for a ratio of opposite over hypotenuse. We'll practice some exact examples, and then you may get the hang of it from there. Write the trig ratios for the acute angles. So it's going to ask you to write the trig ratios, and whenever you see trig ratios, you're going to write the sine, the cosine, and the tangent. Always for the acute angles, we can't use the 90-degree angle. Draw this triangle if needed, otherwise it's in your handout. The acute angles are A and B. We can't use C, and it makes sense because opposite of C is the hypotenuse. We can't have C be the opposite and the hypotenuse, and we can't have two adjacent sides. So we're only working with the acute angles, and it's written properly like this. The sine of A equals. Sine of A equals. Go back and look at your chart. Sine of A is opposite. What side is way over here opposite of angle A? It's little a. And notice the capitalization, just like when we use the Pythagorean theorem. It's always little lowercase letters for the sides, capital letters for the angles. Opposite over hypotenuse. So the sine of A is A over C. Of course, we're going to put numbers in these next, but right now you just got to get the hang of what this is asking. Then we'll do the cosine of A. And the cosine of A is adjacent over hypotenuse, B over C. Sine and cosine will always have the same denominator. Tangent, however, will not. The tangent of A is opposite, which is the A, over the adjacent side. You don't use the hypotenuse, opposite over adjacent. But it also wants you to do the sine, cosine, and tangent of B. It said of the acute angles. So I'm going to do B over here. the sine of B. Now we switch spots. Which side is opposite of B? If you look opposite of B, little b. Where's the hypotenuse? Still C. Cosine of capital B is adjacent, next to A over hypotenuse, C still. And the tangent of B equals opposite over adjacent, B over A. Take a look at those 6 fractions and see if you see a pattern or anything that you can point out. Pause it if you need to. You might have recognized that the cosine of A and the sine of B are exactly the same, B over C. But if you flip-flop it, sine of A and cosine of B are the same. Well, it makes sense. If something is opposite of A, it better be adjacent to B. So those will always have the same fractions. Those will always have the same fractions. Look what happened to your tangent. It's the reciprocal. If it was opposite of A, opposite over adjacent, then it's going to be adjacent to B, opposite over adjacent. Let's try one with numbers. We'll let this all soak in a little bit. I think it might be new for all of you, but we'll get the hang of it. We'll start with x up here in the corner. We're going to do the sine of capital X. If you need to, write SOHCAHTOA down every time you change the page so that you have something to reference. And make sure you spell it right. If you spell SOHCAHTOA wrong, then you're going to do your ratios wrong. Sine, we need opposite over hypotenuse. The opposite of the x is 18. The hypotenuse every single time, and you probably should label it so that you use it every time because that doesn't change, is 30. Don't even ask me. Should we reduce that? Yes. Oh, for the rest of your life, reduce that. Please reduce it. They're both divisible by 6. Reduce it down to 3/5. Keep it red. So the sine of x equals 3/5. The cosine of x is the adjacent side over the hypotenuse. Cosine of x, adjacent side, or the side next to it, over the hypotenuse. 24 over 30, yes, you're going to reduce it. They're both divisible by 6 again to 4/5. And now the tangent of x equals opposite of x. Opposite is 18 over adjacent. We don't use the hypotenuse. And that's also reducible. Reduce them all. Here's another pattern. The numerator and the numerator become the tangent. 3 and 4 become 3/4 because it's opposite, adjacent, opposite, adjacent. No hypotenuse in there. All right, now we have to do the same, but this time for y. The sine of y. Now everything changes. Now this is the opposite side of y. And this is the adjacent side of y. So opposite over adjacent is 24 over 18. But of course, whoops, don't let me do that. Opposite over hypotenuse is 24 over 30. But of course, we're going to reduce it, divide them both by 6, and you'll get 4/5. Then let's find the cosine of y. Adjacent side over the hypotenuse, 18 over 30. Reduce them both, you get 3/5. Do a quick check. If you did it right, these will be the same. If you did it right, those will be the same. And finally, the tangent of y, opposite over adjacent, 24 over 18 gives you 4 over 3. Not 1 1/3. You need a ratio, 4 over 3. All right, next problem. Write this down. Find the sine, cosine, and tangent of angle W. We're only going to find angle W. First in fraction form, then in decimal form to 4 places. So this will be shorter. We don't have to find the sine, cosine, and tangent of W and V. But it'll be a little bit longer because they didn't give us all 3 sides of the triangle. They only gave us 2. We're working with angle W. And since we're not going to change which angle we're working with, let's go ahead and label right away. I'm going to go all the way across the triangle to the opposite side. Right next to the angle, touching the angle, part of the angle, is the adjacent side. And of course, the hypotenuse, you find the 90-degree angle, shoot all the way across. The hypotenuse this time is on the bottom of the triangle. So we know we need adjacent, opposite, and hypotenuse. We don't have the hypotenuse yet. So you got to go back to what you already know about right triangles and do the Pythagorean theorem. 2 squared plus 3 squared equals c squared. 13 equals c squared. Square root both sides. You leave this as the square root of 13. This isn't going to be fun, but hang in there. At least it's stuff you kind of already know. You've worked with radicals. You've done the Pythagorean theorem. We're going to now find the sine, cosine, and tangent of that. So we'll start with sine. The sine of W, capital W, equals opposite over hypotenuse. The cosine of W equals adjacent over hypotenuse. The tangent of angle W equals opposite over adjacent. It said first in fraction form, then as a decimal to 4 decimal places. If you know anything about radicals, you know that this is unacceptable. It looks nice. It's just a nice little fraction, but it's got a radical in the denominator, so it's not nice. It means we have to rationalize it. Multiply by square root of 13. Whatever you do to the bottom, you have to do to the top. You get 3 square root of 13 over 13. Which is not any more simple than what this looks like, but it's right. You could do the same thing here, or you could just recognize, oh, I'm going to get the same answer except it's a 2 instead of a 3. And of course, this one is fine. Don't turn it into a mixed number. Okay, you also want them in decimal form to 4 decimal places, so we're going to use these little approximation marks saying it's going to be about this, not exactly. You are not using the sine, cosine, and tangent buttons yet because we already know what the answer is. We know this is the answer. This is the answer. This is the answer. If I were you, I would not type this in. Just type the first one in. You're going to get the same result. This is just simplified, but their value is the same. And if you want to save yourself a little bit of a headache or time, you'll just type in 3 divided by square root of 13 equals 0.8321. 0.8321. Then do the same with the number 2. If you got a calculator like mine, you can just scoot up and go over and change that to a 2. 2 divided by square root of 13 is 0.5547. And 3 divided by 2 is, I got to get rid of my approximate, is exactly equal to 1.5. Four more problems. Now this is when you use a calculator. Notice the difference. On this one, we didn't know the angle. We said the angle W. We don't know what the angle is, but we know that its ratio is opposite over adjacent or whatever it is. In this problem, it says we know the angle. We know that it's 40 degrees and we're working with x. So you're going to type in the tangent and notice it gives you a parenthesis again. Most calculators do. 40, right parentheses, equals. Tangent of 40 is 0.8391. So x is approximately 0.8391. Do the same thing for sine of 34 degrees. And I want you to practice these on your calculators to make sure you're doing them right. Sine of 34 degrees, 0.5592. Watch your rounding. Cosine of 62 degrees. Hey, I got a trick for you. If you have a calculator like mine, you see this little fix down here on the decimal point? If you know you're going to do a whole bunch of calculating, you can hit fix and change it to 4 decimal places, so that way you don't have to guess when you're rounding or screw up the rounding. It'll always round it where you need it. So when you do cosine of 62 degrees, you don't have to wonder if you rounded right. It's 0.4695. X is approximately 0.4695. Okay? If you want to get it back, hit second fix again. You change it to an F, that means float. Now, I hope you all tried it on your calculator. Make sure your calculator is working. Some of you have one of these calculators. Uh-oh. There's a chance that when you typed in cosine of 62 degrees, watch what happens. Cosine of 62. I got 0.4695. You got 0.6735. That's because you're in the wrong mode. You have a mode button up here. You have to make sure you're in degrees mode by moving over and hitting enter, so that when you do that cosine of 62 in the correct mode, it'll give you the correct answer. And you can also float your decimal also. If you want it to only go to 4 places, you can do that. But make sure you're in the right mode before you start. I know this is a super long notes, but I do need to show you this video, because the question is, what are all these ratios even standing for? And if you want, you can go here on your own. It basically is showing you how long is each side compared to, and I'm going to zoom way in, how long is each side compared to its triangle. If I change this, nothing changes. But if I change this, okay, I'm changing the size of the triangle, that's still 50 degrees. But if I want to change and see how big is the opposite side compared to the bottom, it's that much longer. That's its ratio. So its ratio is going to be bigger than 1. It'll be an improper fraction. How big is the adjacent side compared to the hypotenuse? So when you get a fraction like 2/3 or 3/5, that's what it's showing you. That's how much smaller this side is compared to that side. How big is the sine compared to the hypotenuse? The opposite side, it's about that far, 0.77. So when it says how big is the ratio is comparing, well, how big is the side compared to the hypotenuse? Or in the tangent, how big is the opposite side compared to the adjacent side? That's what we're looking at. All right, good luck on your assignment. Ask lots of questions if you need help.